The 1A, yeah. So the package is quantreg. Yeah, so my working directory is set, and our data is brvm.csv. brvm.csv. So it has to be read.csv, not read.table. See the difference? We can leave everything as it is to avoid making too many changes.
Yeah, I think we'll just
yeah. So let's see the data. Yeah, that's it. This is the right data. I've been expanding. My space is now less. We are doing quantile regression. Let's attach. At any point in time, you can set your quantiles. We have decided to set them. Can be any number of quantiles. But this was the sequence we set yesterday. From 0.05 increasing by 0.05. Or we can specify the specific quantile we want. So this one is individual quantile. And choose which one we want to use. Our data, the length was what? Then when you also have to look at how long your data is or how big, so that you don't set too many quantiles for the regressions to be very small. Because each quantile will pick some portions of the data. So if your data is not very large and you are setting too many quantiles, it's not helpful. So our data is 2224, 2224. It's not bad. You can use tau 0, which is 19 quantiles. Okay. So yes, but you can run the two. When we get to where we choose which one. So let's run this regression. We shouldn't have errors. So this one does not give you don't see the significance, the t-values. We want to find them from the summary. So what I may want to do is do this first. So this one gives us the standard error, the p-value, and the t-value. Yes, for all the 90, all of them. So normally, because later, so that is this one. So I save the object, I save the summary into the object S on line 21, then I'll capture. So remember now, it's not write.csv, it's capture.output. Okay, that's it. Let me make it qr1.txt. Okay, I then run this line. And we can go to our working directory and open it. It's clearer there to see see the good job that you have done. So you see all the coefficients. And this is interesting. It looks like almost, yeah, but look at the median in the middle. In the middle, you realize that it's interesting. So imagine all you did for toilets. Intercept is not significant. So when you are interpreting the relationship, realize that it's possible that some relationships will be positive, some will be negative. Maybe they are not changing like that. The magnitude will be different. The significance may also be different. So let's see, let's point out where it changed from positive to negative. The slope, let's focus on the slope. We will discuss the issue with the intercept very soon. Negative. That's interesting. So what you will have to think about, I'll show you briefly, is which part is the hedge, or which part is safe haven, and which part is So the next thing that you look at the definition, safe haven is a normal association is no relationship or very weak relationship during normal market conditions. Relationship during unfavorable market conditions and negative. Go to the extreme. Find market conditions. Positive market conditions. Positive market conditions. Positive 50.0.50 lower market. Yes, 3 to be complex on no no finance or 0.0% or under market. Those important, all you want is negative relationship. And it was meant to be as big as possible. Not small. Now, so in this way already, you can see that we have situation. But all the relationships are negative. On the list, then you also have diversification negative order. And then all those areas, all those classifications of why we need to relate this. So if you look at this, let's go to the last slide. This definition, set of definitions for safe haven and hedge. A hedge is defined as that is uncorrelated or negatively correlated with another asset or portfolio on average. This is where the on average is the regular market conditions on average. So we are talking about the middle portion. You can look at it from maybe 0.45 to about 0.65. That's still within the larger chunk of the middle. An asset with hedge properties can not necessarily reduce losses in market turmoil or okay. So which means it is not in the extreme market condition. The assets have positive correlation during these extreme market conditions and during normal times experience negative correlation. The key point is that they have a negative correlation. Then a diversifier. A diversifier is brand that is positive, but not certain. So it can be more or the way. So if another asset on average, so positive and very small. Just as for hedging assets, an asset with diversifier characteristics will not necessarily ensure loss reduction. Next market from not being negative. Then go to the safe haven. Uncorrelated, which is 0 or negative. In times of market stress or turmoil. So this is where the safe haven is. What's the what we doing this? market conditions, with an asset use losses for you. So normally what we do is that if the sampling, can give the sampling in any derivatives of quantiles where they are and say there's the recipe grades ahead with quantiles or is a so it's always going to create a summary table, and then very soon we put them in the plot as well. And I'll open some of the papers for you to see briefly. So this is the quantile regression. I'll show you something else. Let's go back to the code. Summarize that. So for this one, realize that you all need to talk about the one portion of the talk about the math. So we are starting the revision and then we have to now relate it to the tangents of power and this and all the various distribution then you, as we are saying, you want to create a summary table for that. I'll show you some from the best. Okay, let's go back to the code. Now, this is exactly the same thing, only that we extract the coefficients into Excel. It's the same thing. We are using tab 0, that's the one that has more. So you can make the change. You're only extracting the coefficients. So you see that when we were rounding to order number, you know, we put the round and then now you can just COEF, this will take only the coefficient for you. And that's important because in this kind of analysis, you want to plot your coefficient. And it will be a row, so you can just transpose them and plot. So every line is very important for easy presentation of your results. If you run this line, you go into our output. You are working there. Where is it? One name. Okay. We have not written it yet, so let's write it now. KRBRVM. RBRVM. Eh? Great. Now we can open it and see. Okay, so I hope by now you know that these codes that I'm showing you, if you look at my papers, these are the codes that wrote the papers in that order. So most of the things in the code, most of the lines are important for easy presentation of our results. So now you have your coefficients in this format. You don't have to now go and type each one of them 90 times like that. So later you realize that you can just transpose this and plot them. We'll see very soon. We are going to debate on whether we should keep our intercept or not. That one will agree. For some time, I was using the intercept. Later, I realized that it doesn't help the relationship. So I removed them. So for you, we will see whether it's good to keep it or not. Or you can check in the specific data set if the intercept should be kept or not. Okay. So this is where we are going to do that test. But before that, we want to plot the coefficients briefly to see how they behave. Okay, so If you run this line, it will open a PDF file for you in your working directory. Then you can put the plot inside. When you finish, you need to, that's why I've intentionally brought this line up here. Once you run this line, you need to run this line also to close the PDF file that is open. So dev.off means open that, close that PDF file. So if you run this line, your PDF file will be there. It will be a blank file until you run the next line. Okay, so let's do this. Do this. So you won't see anything here. It's saved in your working directory. Let's go and see. I saved it as well, QR1 or G. This is old QR1. Can you give it a name that you want?
So,
It's straight away. Why most of them are similar? Yeah, the zero line. That's it. Okay. So okay. There's another one with the content around. So these are the coefficients. All of them are negative. These are the quantiles. 0.05 or 20, 40. But maybe you don't want to present this plot. Red line. I don't see the relevance of the red line now. But in the next plot, I think they put a confidence interval around it to know what you want are really significant. But we don't really need that because we have the PDFs to tell us. No, we have the what? The p-values to tell us. Okay, so let's open it, the PDF again, and plot this one and see. Did I give it a new name? So it's the same name, so it will overwrite it. I didn't close it, right? So since it's not closed, let me see. What did I do? Okay, just a moment. And not shut down device because PDF is opened. Okay, so oh, it's not opened. Okay. Again. So this one. Okay, so you have to close the PDF and just a moment. So you need to close the PDF. If you have a PDF file on your PC, close it before you shut down with the dev.off. Okay, so this PDF here, I have to close it. Then, if I run this line here, I have opened another PDF that I want to put a plot in. So I'll come here and run this line. The plot is done, but I need to now close the PDF process. Are you following? Okay, so this is what will happen. Run this line. Okay, run that line. Then come here Come to plot the one with 95%. Plot that one, run that line. What is in the plot? Yes. In your work. Oh, you can actually crop it and paste it in Word. You can crop it. Yeah. So when I'm doing quantile regression, I don't use this plot. It's not nice enough for me. And I don't even interpret this one. I interpret the coefficients I compare with QQR and I plot that in Excel. But in R, this is in PDF. The other plots that are not in PDF, you can just copy them as bitmap image and we paste it in Word. Those ones are clearer. Okay. So, okay, so with the intercept, so this is where it is 0, right? And remember the 50th quantile, which was insignificant. So that's the one that is the same as 0. And this one also gives you a very nice confidence interval. Okay. So let's check if we should keep the intercept or not. That's the one you should check. Previously, I was not checking. I was just using them. Recently, I realized, no, the intercept is not helping. Okay. So that is this. So this is just another way of doing the plot. We can skip this one. Another way. So it's the same thing.